Remediation Service International, a division of Innovative Environmental Solutions, has been providing engines worldwide for air pollution control to the oil and gas industry since 1985. That's 34 years of proven experience that you can count on for your vapor control needs. Controlling vapors from soil and groundwater remediation projects, rail car and centrifuge degassing on land, barge degassing at sea, above ground tanks at tank farms and refineries, RSI will design the right vapor recovery unit for your specific needs. RSI's VRU technology is unique. It is infinitely scalable by using any size engine or multiple engines that automatically turn off and on in real time as necessary to process any flow from any source. From a smaller 40 kW generator to multiple 1 megawatt generators, we have the right fit to meet your need. This animation of an oil recycling facility tank farm located in Saraland, Alabama, shows where we use asynchronous generators to convert waste gas into electricity that is distributed to the local grid. We turn waste to watts. Why use engines? First, an engine is a positive displacement pump that can be sized to meet any need. Second, it is safe compared to competing technologies because our process is under vacuum up to the moment of combustion. There is no chance for leaks to atmosphere. Other air pollution control equipment have energy pushed to it. Therefore, the process is always under pressure, adding undue risk. Our engine is also the air pollution control device. Vapors enter the intake manifold via our carburetor and are distributed to the cylinders of the engine, where they are oxidized during the combustion stroke before being exhausted to atmosphere. Unlike other control technologies, there is no open flame because combustion takes place safely inside the cylinder head. Again, mitigating risk, making for always safe operation. Most important is that our engine emissions are second to none. Destruction rate efficiency of volatile organic compounds is greater than 99.9%. NOx is less than 50 parts per million by volume out the exhaust. This block diagram illustrates the three major components: the Phoenix 1000 air fuel controller, the Phoenix emissions tracking carburetor, and of course the engine used for vacuum, power, and abatement. The carburetor has three valves that control air, fuel, and process gas. The controller maintains the proper fuel mixture to the engine at all times based on multiple feedback loops. The engine provides all necessary vacuum and power for operation while also controlling emissions to atmosphere. RSI's intuitive operator interface is extremely user-friendly. The dialog boxes on the left-hand side of the screen and those shown in the piping and instrumentation diagram capture all pertinent information. All displayed information is saved in programmed intervals for future retrieval. Please notice that there are 11 other tabs of information. However, for today's demonstration, we will only be referring to the Engine Save tab. Referring again to the piping and instrumentation diagram, the process flow begins at vapor from extraction process. Then the vapor flows through the process valve into the carburetor, where dilution air and alternate fuel are added as necessary to sustain combustion. The mixture is combusted in the engine and exhausted to atmosphere. Pay close attention to the following dialog boxes throughout this demonstration. Conditions will be changing to compensate for the addition of load and or changing BTU content of the process gas. Let's start the engine. Our three carburetor valves, atmospheric air, alternate fuel, and process gas, begin calibration. The engine starts using atmospheric air and alternate fuel like any other engine. Note, at this time, the engine is only experiencing parasitic load. Parasitic load is where the generator is not generating electricity. This results in manifold vacuum greater than 19 inches of mercury. Notice how far open the carburetor valves at this operating condition. We'll be looking closely at these valve positions and flows throughout this presentation. When the precat temp reaches operating temperature, the controller switches to run mode to continue to warm up. Note the alternate fuel at this current RPM and parasitic load. After run mode is initiated, the controller switches to O2 mode, where it is ready to process vapors. The process valve on the carburetor that is connected to the vessel requiring air pollution control begins to open. Notice the controller is constantly adjusting alternate fuel and air dilution valves as necessary to maintain a near stoichiometric air-fuel ratio. The definition of a stoichiometric air-fuel ratio is the perfect air-fuel mixture for combustion. Notice the exhaust flow at this RPM and the parasitic load. Watch what happens when we introduce petroleum hydrocarbons to the process stream. What you are about to witness is what makes RSI's control technology different from any other air pollution control equipment. The process valve is opened as far as possible with only parasitic load. Engine manifold vacuum shows result of current load. Process flow increased, dilution flow decreased, alternate fuel usage remained the same. The engine being a positive displacement pump makes predicting total throughput at a given RPM and load very predictable. Now we begin to introduce unburned vapors into the process flow. Watch as British thermal units per hour, referred to as BTU per hour, and parts per million by volume, referred to as ppmv, are in the process stream increasing. Note that the alternate fuel valve on the carburetor is closing. Notice that fuel flow is decreasing. Notice that exhaust flow is still the same because we have not started generating any electricity. Notice that alternate fuel is for all practical purposes turned off in less than 1 minute because of the introduction of petroleum hydrocarbons into the process stream. How fast we can respond to these changing conditions is what makes RSI technology remarkable. Notice that the process stream contains 16,800 parts per million by volume of vaporized gasoline at 114 mole weight. That translates into our processing approximately 254,000 BTUs per hour of gasoline vapors at parasitic load. Next, we increase load by generating 40 kW of electricity. By increasing load beyond parasitic load, we increase throughput capacity by more than 50%. This is how we size engine and generators to meet whatever specific needs for air pollution control you may have. Watch what happens as we ramp up to 40 kW. Engine manifold vacuum drops, as measured in inches of mercury, from 20 inches to 14 inches. The carburetor valves open further to compensate for this change condition. Exhaust temperatures increase because of additional load. Increased throughput, as noted by engine exhaust flow. BTU per hour remains the same because we haven't changed the amount of energy coming from the process. ppmv decreases because of the diluted process vapor. Now that we have reached 40 kW, watch what happens as we start allowing more energy into the process stream. Please note that changes in load and energy content of the process stream actually happen simultaneously in actual operation. However, they are done individually for the purposes of this demonstration. Notice as BTU per hour and process flow rate increase. Notice as alternate fuel usage decreases to almost zero. Notice BTU per hour increases from 250,000 to 450,000 BTU per hour. Notice process flow rate increase. Notice exhaust stack flow rate increases by more than 50%. To demonstrate how fast we are able to keep up with changing conditions, Watch what happens as we quickly remove gasoline vapors from the process flow and then immediately add them back. No other air pollution control device can match our carburetor controller's ability to maintain a near stoichiometric air-fuel ratio with multiple changing conditions. Operating an engine generator as an air pollution control device is challenging because of the ever-changing conditions. However, years of doing so has put RSI at the forefront of this technology. To summarize, RSI's air pollution control technology is the only air pollution control device able to use 100% of the process gas as the primary fuel source. Turns off alternate fuel when the process stream has enough energy to support combustion. Allows for a 99-to-1 turndown ratio, resulting in less alternate fuel use. Turndown ratio improves when multiple engines are used because we can turn them on and off as needed to meet real-time needs. Most important is that our technology provides the lowest possible cost per kilo of hydrocarbon destroyed, resulting in reduced O&M costs. Is able to convert the waste vapor to usable power. Our engines are safer to operate because there is no open flame and the process is always under vacuum. We meet strict emission standards like those issued by South Coast Air Quality Management District located in Southern California. After witnessing our systems in operations firsthand, South Coast Air Quality Management District noted our technology as BACT, Best Available Control Technology. Our engines don't require any grid power. This results in reduced greenhouse gas footprint when compared to other VRU systems that require to plug into the grid to operate. Producing valuable carbon credits when generating electricity is a plus when using our engines. We can process whatever flow rate at any BTU per hour as needed to control fugitive petroleum hydrocarbons from any source. RSI will design whatever configuration VRU necessary to meet your most challenging air pollution control needs. Our engines, coupled with our proprietary patented air fuel controllers and emission tracking carburetors, are unparalleled when used for air pollution control. Why waste energy by flaring or other means of vapor control? Where else can you find air pollution control equipment that will actually pay for itself over time? Waste to watts air pollution control. Truly a RSI innovative environmental solution. Thank you for your time and consideration.